Hello, it's Mr. Primer here, and in this video I'm going to be showing you how to draw a ray diagram for a plane mirror. So first I'm going to make a little plane mirror that we can practice on, and these dashed lines represent the non-reflected side. So the reflected side is this side right here. Now I'm going to draw an object. Let's pretend it is a pencil. So there's our object right here. So the first thing we're going to do is draw a ray of light that's bouncing off this pencil and going perpendicular to the mirror. So we're going to get our ruler lined up so that it's perpendicular. We're going to bounce it off so it's perpendicular to the mirror. And because it's going perpendicular to the mirror, it's going to bounce straight back like this. So there we go. Alright, so that's one ray. That's the one thing that's going to happen. Now, another ray is going to bounce off, well, they're going to bounce off all over the place. But to simplify this diagram, we only need to draw two rays. So it doesn't matter the angle that you choose, but I'm going to put the angle up to make my diagram less messy. So here we go. There's one ray that's coming here. But now I need to figure out the angle that it's coming in on. And so first I'm going to just focus on this point right down here, make sure that this is lined up with the base of the protractor, and I'm going to go up here and put a little point where it says 90 degrees. And then I'm going to get my ruler out and draw this in a dashed line because I just want this as a reference point. This point is called the normal. So here we go. This will be our reference. So it's 90 degrees from the mirror. But we want to know this angle right here. This angle is called the angle of incidence, and the angle, we use this symbol theta, and for incidence we use a little tiny I. So let's measure this distance now. So we'll put our protractor right here and measure from the 90-degree line that's lined up with the normal to this angle, this ray of incidence ray. So we don't use these numbers 60, 70, 80. We want to know the distance from 90 relative to this angle of incidence right here. So here is 10 degrees, here is 20 degrees, and we need to go up here to kind of figure it out. So it looks like it is about 25 degrees, maybe 26 degrees. So let's say 26 degrees. So we'll put that right here. 26 degrees is the angle of incidence. So now we're going to put 26 degrees on this side because the law of reflection states that the angle of incidence is going to be equal to the angle of reflection. So now I'm going to put 26 degrees on the other side, line it up with the normal, line it up with the back of the mirror, and we'll go 10, 20, 25, 26. There we go. So now I will draw that in, and we'll connect this point with this point and draw our reflected ray. And so, like I said, the angle of reflection is also 26 degrees. So that's this angle right here. So comparing it with the normal. Okay, so now we have two rays that are coming from this point. So light's bouncing off this pencil and going to the mirror and bouncing back. And here are just two of the many rays that will happen to you. But we're kind of picturing our eyeball back here somewhere. And our eye is seeing these two rays, but they're diverging. They're not coming together. They're going further and further apart. And so our brain doesn't recognize that as a single point. It knows that the image isn't going to be over here. It thinks that if this ray is going this way, this ray is going this way, then the point of origin where they meet up must actually be somewhere over here. So our brains are really smart that they can do that. So what we're going to do, because they're diverging, we're going to make them converge on the other side of the mirror, and we're going to use dashed lines to show that. Let's make sure that it's lined up properly. Okay, so there, There we go. Okay, so there's one dashed line, and then the other dashed line will be right here. So we only draw these for the reflected rays. So notice that I'm not putting it on this line right here, because this is an incident ray. This is the light coming into the mirror. We're only looking at what our eye is going to see, the reflected rays. And so now we'll know that this point is going to be right here, because that's where these two line up. So if we call this point A, we can call this point A. And this is our object. It's what actually exists. And over here is going to be our image. So now that we've done that point, we're going to do the same thing over here with this point. So pick this point right here. The first line is easy, just a ray that goes straight in, perpendicular to the mirror, and it will bounce straight back. So we'll put the arrows going both ways to show that. Now we'll draw any angle, it doesn't matter which one. And we'll draw the arrow to show that it's coming in. Now we need to make a normal. So we'll put the protractor, line it up here. And here is 90 degrees. So that's where our normal is. Okay, so that's 90 degrees right there. And so we want to know this angle right here, the angle of incidence. And so if we measure it, let's see what it is. Okay, look, it lines up very well. Look at that. So it is 1020. It's coming in right here. So 20 degrees from the normal. Remember, we line up the 90-degree line on our protractor with the normal, and we go 1020. So that is 20 degrees. Okay, so then we will come over here, put this back on, and we'll go 20 degrees this way. So 1020. There's 20 degrees from the 90-degree line, from the normal. And then we will line up our protractor. Here we go. Oh, I went too far. Whoops. I got a little carried away here. Look at that. So what I need to do is just erase this, because this side is supposed to be just dashed lines, because that is the reflected rays, or the virtual rays. Okay, so we're drawing the virtual rays on this side, because once again, these rays are diverging from each other. So our brain sees them as separating. So our brain is really smart and wants to figure out the point of origin. So it retraces these off of the reflected rays. And so where these two converge, that's where that point will be. So we can draw that in now. That is our image. Woohoo! So we have our image. And to help us better understand this image, we can think of its properties. So here are the properties that we're going to be looking at. So S for size. So is the image smaller, or actually I'll move this up a little bit. Is the image smaller or larger than the object? Attitude is a physics term, and it means is this upright or inverted compared to the object. Location is looking at the distance from the mirror. So is this distance closer or further than the object to the mirror? And type, is it real or virtual? When you're dealing with mirrors, virtual images appear on this side of the mirror, and real images appear on this side of the mirror. So this image is a virtual image, and that's also why we use these dashed lines. Virtual image means that there's no light actually converging at these points. It's actually our brain just extrapolating this information and making an image out of it. So let's write that down then. So S for size. So size, if you look at these, they are the same size. And you could also just put a magnification of 1. To find the magnification, you can go the height of the image divided by the height of the object. And since they're the same size, it'll be 1. A for attitude, so this is upright, because point A is the top of the diagram in both points. You will notice that it is actually inverted laterally. So and this side is slanted to the left, this is slanted to the right. And so that's why when you're looking in plane mirrors, words appear to be reversed or flipped laterally. But we're not putting this down right here for these properties. And then L for location. So it is the same distance. So same distance from here to here as here to here. So same distance or 1 times. You notice there's a relationship. So the magnification here will be the same ratio as the distance of the image to the object. And T for type, as I said before, it is virtual because it's on this side of the mirror, and it has these dashed lines. So that is how you use ray diagrams to find images. And I hope you are having a great day.